Okay, look at that. Okay, so let's go ahead and get started. So I think a few of you probably saw the announcement. I've just decided not to use Skillport this semester. I don't like doing kind of changes mid-semester, but if we're going to do them, I'd rather do them now than later. It's just not working out for this class this semester. Yeah, so I don't want to get, and I don't think anybody got too far into it, right? How many? Does anybody in here like get more than a few of the videos in? Okay. If anybody did any quizzes or anything, I guess later on this semester we can decide about some extra credit or something like that. Did anybody actually finish any quizzes in there? Okay, so everyone's pretty much at a blank slate. So that actually, I guess, worked out. So what I'm going to do instead is record my own lectures. You're still more than welcome to go inside of Skillport if you want to study for the Linux Plus exam. But I'm not gonna pull any, like, your midterm and final will be from the lectures that I provide. Okay. Normally, what we'll do is I'll pre-record the lectures, and you'll be responsible for watching the lectures before class, and then we'll do some sort of in-class lab or something like that. This week, I just want to do a regular lecture to kind of get you started. Sort of like we did last week, but a little bit more hands-on. And then I think next week we'll start our first in-class lab. Okay. So everyone good with that? Okay. Show of hands. How many people were able to get some sort of Linux environment up and running? You people? Most people? Okay. That's good. So what we'll do today is, if you have your own personal computer, great. Get Linux up and running. Otherwise, what we can do is I can walk you through probably the simplest way if you have VMware to get it up and running. So before we get started, any questions on the course change up?
When is something due? When's our first due date?
I'm guessing it'll most likely be probably the 6th. Okay. So what'll happen is next week we'll do our first in-class thing, and then just in case anybody missed that class, I'll have it due the 6th. And then from there on out, expect about every week and a half for the rest of the semester something due. Okay. So for everyone else, if you're on a school computer, because these are pretty inconsistent about which Linux distributions are installed, what we can do is go ahead and start up VMware Workstation. And still no dropped frames. Perfect. Streaming, everything looks good. So what I have is on one of our local servers, so there's a lightweight distribution, so it's a lightweight variant of Ubuntu, and I don't know how to pronounce. I guess I've always just called it Xubuntu. It's supposed to be a little bit more lightweight, and to me that kind of works well for virtual machines. So if you click this, so if you already have your own setup on your own computer, just get it up and running. That's fine. But if not, if you're on a school computer today, go ahead and click this. I'm going to save it to downloads. Shouldn't take too long. Imagine a minute or two. This link is actually on one of the servers on our local network, so it's going to be a little bit faster. Then what we can do is, rather than having to actually fully install, there's this idea of a live CD. I guess I can briefly go over that. So they call them live CDs because, you know, that's kind of the era they came out when you actually had a bootable CD. But it's this basic idea that you can run the operating system without actually having to install it. And not a lot of operating systems out there really do this. The reason being is because most of the time, like say for example, Mac OS, you can't really just try it, you know, like you kind of have to have a Mac computer. It's probably already going to have the OS anyway. Generally, same thing for Windows. Because so many people wanted to try out Linux, before actually installing it, these became really, really popular because it gave you a way to try out the operating system without having to make any changes to your disk. And this was actually kind of maybe 10 years ago these started to get popular, maybe even longer. And that was kind of the days before you could get VMware for free, or, you know, so. In the old days, you'd literally just download one of these, have a CD, pop it in, and then you could run it without changing your operating system. But today we have VMware, we have all kinds of other cool things, so we have some other ways to do this, okay? Don't forget, last week we went over all the different ways to install it, okay? Just by show of hands, I'm guessing the most popular is probably VMware. How many people did VMware? Most people? Okay.
I have it, but I didn't do it for last week. I did it last semester downstairs in the lab, and
Okay.
I don't know.
Well,
Sometimes when I get the right things, and sometimes I don't.
okay.
I did a live USB.
Mm-hmm.
It wouldn't save me my changes when I was in there. It just like let me try it out.
Correct, yeah.
Yeah, so everything just wipes out when you restart it.
Yes, yeah, so just to let everybody know, that's exactly right. Yeah, the whole point is so that it doesn't ever touch your hard drive or make any changes at all. So it actually operates pretty much completely in RAM or read-only from the flash drive.
Will you need the saver keys?
No, you won't ever need to.
Okay.
Usually what you'll do is there's a command that you can record, like all the commands you're typing in, and then what it'll have you do is take that and copy and paste it into Blackboard. And then so what you'll probably do is just open up a web browser from Linux and then upload it. Okay. So for those of you that don't have your own computer today, how many people are still downloading the ISO file? Everyone's got it downloaded?
I already have it.
Are you on your personal computer or school computer?
I'm on the school computer.
Okay, yeah, so if not, you can just go ahead and click this,
I
the
did.
one that said,
Click that.
and it probably ended up in your downloads.
Yeah. Well, it says here. Yeah.
Okay.
It's like a menu.
I'll help you find it in a minute. Yeah, so don't double click it, by the way. We just need to download only. And then open up VMware. And then we want to make a new virtual machine. Now the reason I'm not bothering installing it is because A, using the live CD is much, much, much quicker, but B, I have a feeling these machines are going to get re-imaged sometime in the next few weeks, and it'll just have to reinstall it anyway. So, okay. So, and by the way, this is just to let you know, this is being recorded. So if you fall behind at all, like I know some people like to take notes. I'd rather have you follow along, and then you can always go back later and rewatch and take notes. Okay. So what we're going to do is, it's kind of counterintuitive, even though we just downloaded the ISO file. So what I did, I went to Player, File, New Virtual Machine. Even though we have the ISO, we're going to say, I will install the operating system later. What happens is, if we provide it with the installer now, it's going to want to actually install it. It's not going to want to run it as a live CD. So go ahead and have this checked. I will install the operating system later. Linux, Ubuntu. Even though we're using a variant, they all have essentially the same underlying core packages. Yes?
Does it matter if we use a 64-bit version?
So don't do it from the website. Do it from this one I said. Are you on your own computer?
No, I'm on
No, the drop down.
Yeah, I'm on the drop down.
Ubuntu 64-bit.
Oh. Yeah, it's a 64-bit image, so we can go 64-bit. I'm pretty sure it is. It's usually in the file name. Yeah, AMD 64. Yeah, it's 64-bit. Okay, so Linux, Ubuntu 64-bit. Can leave the default name. Does anybody already have one called Ubuntu installed that it had like put like a 2 in parentheses or anything like that? No. Okay. And then next, because we're going to be running it as a live CD, we don't really need a disk. So we can just set this to 1 gig. Actually, I think the smallest you can set to is 0.1. Unfortunately, they don't let you set it to 0. We actually really don't need a hard drive, but that's fine. And all these defaults will be fine. Okay, so is everyone at this screen? You're able to keep up? Okay, let's go ahead and click finish. So now if we go to play virtual machine, actually, we might have needed to do 32-bit. I'm gonna have to delete that and go again. Does everyone have a blank screen that did 64-bit?
No, I didn't have a link.
I have updates, software updates.
Did you want us to hit remind me later? On the,
Yeah, yeah. Don't run updates.
It will remind you later, but it says client MAC address and it's doing stuff.
Mine says
Including
not
Intel.
installed on this first boot.
Operating.
Okay, let's do this.
Down.
Let's just do that. Close this out. Power off. Let's do the one that didn't say 64-bit. When I tested this method earlier, I didn't even think to check to see if there was 64-bit available. So that's going to probably hang for a minute. Go ahead and open up a new VMware. Well, that one closes. And let's go through that process again, but we'll just not take the 64-bit version. So player, file, new virtual machine. I will install the operating system later. Linux, and then let's just Ubuntu Linux. You can leave the default name. And then just in case it was having any weird issues with disk size, let's just go ahead and set it to 1. Doesn't actually need 1, but I don't know, maybe it was complaining about that. Click finish. Now let's go ahead and power on play. There we go.
What did you click, play virtual machine? Or did you put something else on the left?
Just the green play arrow.
Right, on the bottom, right?
Yeah. Oh, I'm sorry. So we do need to, yeah, so it's not gonna, that's why it's not working. Sorry. Okay, any guesses why it didn't do anything?
Because you have to guess the operating system set to Linux instead of Windows.
Well, because we have to actually point it to an ISO. Forgot that part. Okay, so go back to this screen. Bless you. And then edit virtual machine settings.
What should I click now? Suspend, power off, or cancel?
Power off. And then we have to set, so we right click, go to settings, and then point this to an ISO image. And then mine's in the downloads. That's why it was a blank screen, because it didn't have anywhere to go to. Yeah. And then now you should be able to boot it up. Should have been, it was an instant red flag when it was looking for like a network boot. I couldn't find anything.
Okay, so now mine says virtual machine name Ubuntu 2 in parentheses, right?
Cancel. So right click here.
Right, click where, here?
Ubuntu, yeah.
Oh,
Go to settings. And then go to CD drum. ISO image. And browse. And then it should be, did you put it in your downloads? It's probably in
no,
the
it's down
downloads.
here.
It's most likely in the downloads.
demos.
Okay. And then now you can double click it or hit play. Okay, sorry about that. Little misstep. All right, is everyone on the screen now? Okay, so we can go ahead and just click try. And then it'll boot up into an environment that we can use. Yes.
Kind of irrelevant, but the next course, COP 2000, would that be recorded as well?
It's the pre-recorded summer lectures.
Oh, yeah. You're
Yeah.
right.
Okay. We'll just pause for a second here. Is everyone at desktop?
I could try.
Yeah, it just takes a second to get going.
Take 1 second. Click it again.
No, it's probably going.
Okay, on the left it has English, all these languages opened up. Try clicking.
Highlight English.
You don't need, yeah, if you defaulted to English, so just click try. One thing to note sometimes with VMware is like where it's capturing your mouse cursor. So sometimes you are in here and you think you might have clicked something and it just brings the window to focus, so you might have to click it again sometimes. Okay. So as far as VMware tools, just do never remind me because we're actually going to take a nice little detour on that. Okay, so you can see here, it's probably kind of annoying having this tiny little thing right here. So we're going to learn our first command today. So click this little, I don't know what they call it, the equivalent to the start menu, I guess, in Windows. So we're going to spend about 90%, probably 99% of the time in terminal. So go ahead and click this, go to terminal emulator. And you make these fonts very large so everyone can see them. By the way, so for many of you, the default fonts might be too small. So if you want to change that, you just go to Edit, Preferences, Appearance, and then just set the font. So I'll set it very large so everyone in class can see. Now obviously this is like obnoxiously unworkable. So there's a package that we can install. This is only if you're on VMware. So what we do is type sudo apt install open VM tools. We'll get to much more basic commands in a second, but this is one of those annoyances that I think most people are going to be happy to hit enter. So it's sudo apt install open-vm-tools is the package name. And then hit Y and then enter. Now, it probably doesn't look that different, but if you just restore it and then make it large again, it sets up all the pass-through drivers and all that sort of stuff that needs, okay? So all that's just kind of the precursor stuff to get us up and running. Now we're basically ready to start commands, okay? Doing pretty good, not dropping any frames or anything. Might just do this. Just make it wider. Okay, so everyone at that point that you've got like a usable terminal, you can actually see it. Okay. So let's start off with the basics. So last week we talked about what the kernel is and Linux distributions and some of that other conceptual stuff, but now for the most part I want to keep this class geared toward practical stuff. Again, if you're more concerned with the exam and terminology and stuff, you're more than welcome to use Skillport, but I'm just going to try to stick to things that are useful to you as a Unix, Linux administrator, or somebody trying to use it maybe as a developer, or even just, you know, generally just trying to learn the most useful parts. Okay, so there's this idea of a shell. Well, let's take a step back. So when you hit the power button on the computer, it goes to the BIOS, and then it looks for the operating system. It finds the operating system, gets the kernel, the whole thing boots up, and then we get to this thing called a shell. The idea of the shell is that it gives us a way to interact with the operating system on the command line. And the shell itself is actually just a program. Okay. Now, usually we think of running commands. There's not really the idea of commands in Linux. Everything's just a program. Does that make sense? So like in Windows, if you ran ipconfig, that's a program. You know, same thing here. If we run anything, it's just essentially a program. There's some special cases where there's things called built-ins, but don't worry about those too much right now. So I'll often use the term command and program interchangeably. So like the first command that we're going to learn is like ls, and there's an actual program called ls that lists all the files in the current directory, but I'll often use it interchangeably. Okay. So there's a bunch of different shells, but most of the time in most Linux distribution, you're going to be using a shell called bash. There's a bunch of others, and they have pros and cons, but just to keep life simple, we're just going to stick to defaults mostly. By the way, so before we even start that command, so you already ran a command. Most of these terminals, by the way, you probably don't even think twice about it, but if you've used like Windows before, but if you hit the up arrow, that gives you your command history. Kind of a useful little thing.
How many times does it go back, 3 or more? There might be a limit.
There's a limit, and there's a system variable that holds that. Usually, by default, I think it's either 1,000 or 10,000 or something like that. Yeah, so it's pretty large.
Okay.
But because we haven't, you know, done anything else, that's all that's in there. Now I'll teach you very quickly a useful command, clear, because a lot of times it gets a little bit too busy that it's kind of difficult to read the command. So you'll see me clear the terminal all the time. So after we boot it up here, so do ls. ls lists all the files and directories in your current directory. Now, what's a directory? You can think of it, if you're from the Windows world, just think of it like a folder. Okay. Remember that the original Unix operating system was created in the 70s, and so maybe there wasn't some agreement on the terminology, but you can I don't get too caught up in terminology. You can think of it as a folder. Okay. Now, you don't have to do this, but just to give you a sense, if you're using a file manager, you can see that all we have inside of here are directories. Okay. Now, the nice thing about a lot of these modern terminals is they have some sort of colorization, and by default here we have all of our directories are like a dark blue. I'm actually going to change, if I can do it quickly. I don't know which ones. This one might be easiest to see. Okay. Can everyone see that okay? I'll go a little bit larger with the fonts as well. There we go. Okay. So let's just walk through some basic commands. If I want to make a new directory, mkdir, and then the directory name. So let's just say I wanted to call it Testdir for test directory. I do an ls, and it lists all the files and directories in the current directory. And we can see here that we have Testdir. Now, your first thought might be, well, yeah, this is in color, but is there like a text way I can tell if this is a directory or a regular file? Now, in the Windows world, we can pass additional options to a command. Like usually people use the slash. But in the Unix and Linux world, we typically use a dash. And so one of the most common arguments to pass to ls is -l, and it gives you the long listing of it. We'll talk about what all this means later, but just know for now that if you see a D at the front, that means it's a directory. Okay. And Testdir that we just created, we can see here that it has a D in front. Now, what if we wanted to go into that directory that we just made? So the command for that is cd. Now, a quick little thing. How many people know about tab completion? I imagine most people. Yeah, so for those that don't, tab completion is this idea that we can start to type part of the command and then hit tab, and then it fills it out for us. Okay, and you can see when we made the directory, there's nothing in here. Now we'll talk about paths in more detail at some point, but I'm in this current directory called Testdir. What if I wanted to go back to where I was? What we call the parent directory. Anytime you want to refer to one directory up, it's 2 dots, okay? So we do cd ... and then that takes us up a directory. We can see here, we're back to the original location. Okay, so the commands we talked about so far, I briefly touched on the shell. We'll probably get into more details, but I want to just give you working knowledge of how to use the system before we get into some of these details. We did ls, that lists all the files and directories. We can pass a -l option, and that'll give us the long output. We did the mkdir to make a directory. We did cd to change directory, and we could pass an option to that where we say the directory name. And then if we want to go to the parent, we use ... Now if we want to refer to the current directory, it's just a single dot. That might seem useless right now, but it becomes useful later. Like I could cd ... but that's kind of a useless command. Usually we use ... in under other contexts.
What does one dot do?
One dot just means the current directory.
Oh, okay.
For cd, it's not super useful, but we'll learn about instances later where dot is useful. Okay. Now you probably already see this slash in front. So in Linux and Unix, we use / as what we call the path separator. So let's say, for example, ls etc passwd. These are going to be the separators. So let's explore the system's directory structure. And maybe I should just keep a, I guess I don't need to. I was thinking about keeping a running tab of the commands that we've talked about so far off to the side, but we probably don't need that. So to find out the current directory that we're in, we do pwd, stands for present working directory. We can see here it's in /home/xubuntu, which is, since we're using a live disk, live ISO, I guess would be the term, it just made a default user. Usually when you run the installer, you'd create users, like you put, whatever whatever name you want. Now, what might seem a little bit off or different is in the Windows world, we typically have drive letters. In the Unix Linux world, we don't really deal with drive letters. We'll get to this later. We deal with things called mount points. But this actually simplifies our life a little bit. Okay? So when we boot up, we have a root directory structure that everything branches off of. Okay? So let's explore that. Let's do cd and then /, and that'll take us all the way to the root of our directory structure. And we do ls. And let's just go through some of these. So bin is short for binary. That usually means like an executable file of some sort. And let's just explore bin. Now you'll see a lot of programs in here. Yeah, so somebody said they noticed ping. We can actually see LS's in here.
So the different colors have different significance, correct?
Correct, yeah. We'll get into those later. Usually you don't depend on those alone. Usually they're just kind of a visual cue.
Right.
If you really need to know what it actually is, you usually rely on ls minus l, and that'll give you the full listing. Okay, so that keeps programs. It doesn't keep all the programs. It just keeps like a minimum core set of programs. So we'll get into some of that more later. Right now we're just kind of exploring. I realize this is very new for a lot of you. Okay, so we're present working directory. We're in /. So that keeps kind of the core set of executable files to keep the system up and going. Like we saw ls in there. Somebody mentioned ping. Any very small editors. What will often happen, well, back in the old days, when we had very, very, very small hard disks, what people would typically do is split up their file systems all kinds of different ways. And if you had to recover your system, usually you wanted a minimum set of utilities. That's what bin was there for. It's like, what's the minimum set of programs that if I need to recover this system are in there. Now, in modern days, a lot of people are a little bit lazier about splitting up their file system. We'll talk about that a little bit later. But boot. Okay, so let's do ls boot /boot. This essentially has files related to booting of the system. Now, the boot process for modern Linux distributions is actually a little bit complicated. It used to be really simple. It was like it would boot, start up the kernel, and then boom. Now they have a more complicated system. It's not as easy as it used to be, but it's still not super bad, but I don't want to get into it right now. CD-ROM. So you remember I mentioned earlier that we don't have drive letters. And so that seems kind of strange. We've just got CD-ROM there. We have this idea of mount points, which we'll get to later on. But what we do, yes?
Sorry. I just got a pop-up. It says that this application doesn't have closed unexpectedly.
Because we have limited class time, I would say just try to restart it.
Okay, I'm good.
And then, oh, it went through. Okay.
Yeah,
Okay. We'll get into this later, but just know for now we don't have to deal with drive letters. What happens is that we have devices, whether that's a solid state drive, a hard drive, a network drive, whatever, any sort of storage, and we make it appear directly in the file system. It's kind of nice because everything branches off of root, so you can find stuff. Drive letters get frustrating because what happens with drive letters? They change. And then you have to get into other ways of accessing that information. And with Unix and Linux, it's kind of nice that we don't have to deal with that. Now here's a kind of a special directory here called dev. Now you'll probably see a lot of things that you're like, what the heck is any of this? One of the things that made, sorry, I just have to OCD check this every once in a while to make sure it's still streaming. Okay, perfect. One of the things that made the original Unix unique, and I think they actually got this from Multics, is this idea of everything is a file. That's not really true in 2020, but early operating systems, let's say, for example, I wanted to access the CD-ROM. Well, they didn't have a CD-ROM back then, but you get the idea. So a tape drive, let's say. What I would have to do is I'd have to write special software to directly access that tape drive. This idea of everything is a file, and again, it's not completely true. Certain things don't follow this, like networking doesn't actually follow it. But many, I would say most things still do. And what they decided was, you know, every piece of hardware I have on my computer, why can't I just make it available as a file? And then I can read and write to that file. So that's why we see in this dev, it's short for device, this generally has our devices. Now, you have to think a lot of these decisions were made in 1970, and for modern systems, sometimes they've had to break the rules a little bit. So a lot of this stuff, I tell you, it's not set in stone. There's always exceptions, but this is still pretty much generally true. And the idea is that if I want to read data from the CD-ROM, I can do that. I don't have to write any special device drivers or anything like that. I just write a program in C that just reads from the CD-ROM. Okay, it's very nice. Now there are things that are not actually hardware. Good example is this one called Null. This is what they call the bit bucket. Anytime you have something that, like, say, output from a program, you can just send it in a null. You don't have to send it to a file. You just want it to go nowhere, just to get tossed away. That's an example of like a virtual device. It's not a real piece of hardware. Okay.
PPP?
What's that?
PPP?
That is point-to-point protocol, I think. That's old dial-up modems,
Okay, I
right?
wanted to make sure it was the same thing.
Yeah.
And that's in the networking.
Yeah.
LAN.
Yeah. Okay. So it's
a file for that?
correct, yeah. So you could actually write a program to directly communicate with that device just by communicating with a file. Okay, so let's, so I'm going to clear. Let's make sure we're still in root. Okay, so let's keep on exploring here. This one's very, very important. ETC. Sometimes you'll hear people pronounce it Etsy, but I guess like, etc. Yeah, short for etc. It's a very weird name. They probably should have called it config, because that's what essentially you tend to store in there is config files. Okay, so if I do ls/etc, you'll see a lot of .conf at the end. Okay. These are generally configuration files. There's this big debate in the various communities as what's the best way to do configuration. In the Windows world, because Microsoft can kind of hand down corporate decisions from above, they chose the registry. And the idea of the registry is that any configuration that you have at all, there's this central database that you read and write to and from. And it's a binary database, and that's kind of the one spot. Programs can deviate, but they're deviating from the norm. In the Unix and Linux world, there was never really a standard set. So what I mean is that in here, you might have files that are plain text files, binary, XML, YAML, JSON, comma separated. There, some of these actually might be scripts that are sourced from. So always keep that in mind, is that you can't just learn like one thing. You have to be very adaptable in Linux, because again, there's no like central corporate entity really handing down a lot of these decisions. The Unix world split very, very, very early, like within 5 years in, and people started to make their own decisions on kind of important things. Okay. So let's just see what's in one of these files. So there's a file called lsb-release. Okay. Now, if we want to see the contents of a file, so we already know these are directories in the dark blue. We could do an ls-l just to confirm that. But we can see right here, there's a file up here, LSB release. LSB stands for Linux Standards Base. If we have time, we'll talk about that a little bit. If I just want to see the contents of it, the command for that is cat, short for concatenate. Obviously, you can see why they shortened it, because that'd be a very long command to type every single time. Now let's do /etc lsb release. And you can see here, this just has some basic information about the distribution that we're running. Okay. And again, there's no standards, because you can see here, this is like a key value pair. It's got like a variable name equals this. But if I were to open up another file, let's say this one right here, and a switch, you can see that's in a completely different format. There's generally no central way. There's actually a big debate about this, whether it's better to have a central database with binary files or plain text config files. From a practical purpose, I much actually prefer the plain text files, because it's much less like this. So has anybody ever poked around in the Windows registry before? Show hands. It's pretty difficult to navigate, correct? Like, unless you know where you're going, like you wouldn't just be able to browse through there and find anything. The nice thing about this is that there's a command called grep. And a lot of times, because these are plain text, you can just grep right through the whole directory structure and often find what you want to modify. So just keep that in mind. Okay. Let's keep on going through here. I might go a little bit faster for some of these. Home, that's where all the user's home directories are. Lib, short for library, reusable libraries. This gets into programming a little bit, but when you create a program, there's a couple of different ways to compile that program. I can compile it statically into one large binary program. Now, that can cause problems. Let's say, for example, we write a program that uses encryption. And encryption is very common. So let's say on a given system, just use a round number, there's 100 different programs that have encryption or need encryption. And a very popular encryption library is called OpenSSL. Well, a few years ago, there was a really, really bad OpenSSL vulnerability. If I've got 100 different programs that are what's called statically compiled, I have to update 100 different programs. The alternative is to use a shared library. On Windows, we call these DLLs. How many people have heard of DLL before? Okay, and that's actually what it is that you take that program and you split it up into the encryption library, OpenSSL, and the main program. That way, if there's a bug or problem in one of these libraries, all you have to do is replace the library and maybe a reboot, and then that's the end of it. Okay, that's where all these are kept. You'll typically see on Linux, you'll see SO, which stands for Shared Object File. They're very, very similar conceptually to a DLL. Mechanically underneath, how they work is different, but they kind of, conceptually for what you're concerned about, they work the same. lib64 is just the 64-bit versions of that. Let's skip these for now. Opt is reserved for optional software. So say, for example, I went out and downloaded, trying to think, a good example might end up in there, Oracle database. Okay, since that's kind of like third-party software that wouldn't be included in the main system, you'd typically put that in opt. Proc is a special file system related to processes and various things like that. Like there's a file in there called CPU info. So if you wanted to get some CPU info, you could cat that. It's got all kinds of interesting stuff about that. There's a special user on every system that we'll talk about called root. Sometimes we'll call it the super user, but root has their own directory. So root doesn't sit under home. Root actually has their own special directory. The reason being is because oftentimes home, you might want to actually keep that remotely somewhere. But if your system's crashed or broken or has had some sort of problem and you don't have network access, you want root to be on the same file system, okay? sbin, anytime you see S in front of a normal directory name, so we have like bin and then sbin, the S stands for super user. Those are typically programs that only root can access. Okay, so for example, if I want to change routing information or stuff related to the file system, it's a good chance that that super user is the only one that can do it. You don't typically want to have a regular user doing that. We'll go through some of these, and then this is the one, I guess, user. So USR, those are kind of, I think officially it's user installed programs, but it's got additional programs and libraries and so on. So you can see here there's a lot of similarities. We've got bin, we've got lib, we've got sbin for keeping source code and so on. Okay. Now, just to let you know, these aren't standardized across even Linux distributions, let alone across Unix distributions. There was a big effort many years ago Linux standard to try to standardize a lot of this stuff. It's had limited success. Let's just say that. Okay. So, long story short, is that you're going to have to know that not a lot of distributions are going to stick to everything that you're used to, but there's a huge amount of overlap. That's, if I had to make up a number, 90% overlap. It's just sometimes you're going to be looking for a specific file, and it might just be in a different spot. The place where you really tend to see it is in config files inside of /etc. Okay, so let's keep on going here. I want to try to make good use of our class time. Okay, but that's the basic directory layout, and maybe I'll post something that kind of summarizes what each of those are. So right now we're in /. If we wanted to get back to our home directory, we could do cd/home/xubuntu. But as a shortcut, what you can do is just cd and then enter, and then it just assumes it wants to go back to your home directory. So I did cd enter. We can see it took us back to our home directory. So we went through some of the various directories that we'll work with over time. I wouldn't expect you to memorize all of them. It's just going to be one of those things, as you get used to the system, you'll just naturally memorize them, okay? And the idea is the names, unfortunately, in 2020, they aren't necessarily super descriptive, like lib. A lot of people might think it has, what's that short for, library, or shared libraries, but you'll just get used to them. Okay, so let's go back to our directory that we have from before. So let's do cd testdir. Now, if I want to, so I already showed you how to make a directory, mkdir, short for make directory. If I wanted to create an empty file, there's a command called touch. And let's just call it hello. Now, one thing you might have noticed is in the Windows world, pretty much everything has a file extension. It's very rare to find files without file extensions in the Windows world. It's actually fairly common inside of the Unix Linux world. We generally very broadly classify files into two types of files: binary files and text files. Okay. Binary files, usually it's a program. Sometimes it can be binary encoded data, but for the most part, for just to oversimplify for what you're concerned about, usually what I mean by binary files, like it's a program, it's a compiled program. But you can store data in a binary format too. So here I'm just going to touch a file. It's empty. If I do ls-l, notice that there's no D in front of it. It's just a regular file. And this is the size of the file, 0 bytes. Now, what if I wanted to edit the file? There's a whole history of what we call plain text editors inside of the Unix Linux world. Actually, if you wanted a heated debate, you could bring these up and talk about them. Emacs, there's another called, I've always said VI. I hear some people say VI sometimes. There's a more modern version called Vim, VI improved, VIM. That's what I tend to use Vim most often. VI is very, I don't know what the right word is. So it was actually originally created to be a super, super lightweight text editor over 9600 baud modems. It was meant to be, if I was connecting to a remote server and I needed to edit a file, and so what did they do? They made these very esoteric command sequences to do anything. Now, if you learn them over the years, I've had to, because a lot of places I've worked we used VI or VI. If you memorize them, you can be really, really, really fast at editing. But for the problem with most people is that with a graphical program, if I were to open up Microsoft Word, if I didn't know what I was doing, usually I can click around till I get something. With VI, you can't do that. It's like you just have to know the command sequences, and there's a super, super steep learning curve. Yeah.
I just wondered if I can recall right. The RW is read and write, and then the last one's read, correct?
Correct. Yeah, we'll go for permissions in maybe next lecture, a couple lectures, something like that. Now, I'm not gonna. Let me think how to say this. I'm not a mean person. I think it's important to learn some of these. I think it's important to learn VI, but I realize a lot of people in here, you're taking this course because you're, getting the degree. And to be honest, to teach you a lot of these, it's going to burn through a lot of time, and people just find it very confusing. So many years ago, there was a simplified editor called Pico. Eventually, and the idea was that it was much, much simpler to use than VI or even Emacs. And eventually, it never really got maintained, and it kind of went away over time. But then programmers always have little jokes to themselves. So there's the editor called Pico, and then the next in line, whoever created it decided to call it Nano. So that's the editor. So long story short, the editor that we're going to tend to use in this course is Nano. Okay. It's good to try to learn some things about VI. If you're really, really interested in it, you can go to YouTube. Usually what people tend to use is Vim. It's a more modern version that has some extra features. But in this class, we'll just use Nano. Okay. So let's edit this file that we just created called hello. So what we do is NanoHello. And you'll notice that this already gives us some common keyboard shortcuts. So let's type in, I hope to learn a lot about Linux. Now the caret, basically what you're saying, press the control key. So if I want to exit, I do Control X, and as you're exiting, it'll ask, hey, you made some changes to this file. We'll say Y. It says, what file do you want to write? Hello, enter. That's about as involved as we're going to get into text editors, okay? Maybe we'll do a little bit of finding, but there's other utilities like grep that actually do a much better job at going through files that we don't typically really necessarily have to rely on the editor, okay? So we've added some stuff to that file. So now if we do an ls-l, what do you notice about the file size?
It has increased to 4.
Yep, it's increased. Mine is 35 bytes.
Total 4 and 35 bytes. What was total 4?
Can't remember off the top of my head,
Oh,
honestly.
I thought that was the size, so you're saying 35 there before the date.
It
is
might have to
bytes.
do with. I don't want to make stuff up.
Okay, no, so then the where it says 35 before January 23rd, that's the bytes?
Yes.
Oh, all right.
Okay. So we have this file, and remember we learned earlier cat.
Oh, so that means it's correct?
Yep. Now, I'll tell you, it probably seems like we're going through a lot of commands, but to be honest, in your daily life as a Linux administrator, you really only use about 10 to 20 commands, but those commands over and over and over again. And then the commands you use less often, typically what you'll do is either put them in a script, keep notes, or refer to the original documentation, okay? So realistically, just to move around the system, use like 10 to 20 commands. Maybe if you've been doing it longer, slightly more, but you get the idea. We aren't going to be learning this many commands every single class. We're going to be using these same commands to learn about Linux over and over and again. But this is kind of like our base level, just to get moving through the system. Now, I will tell you that, quick question. So this class ends at 2:15, right? Just to make sure I have my time. Okay. Now, you'll notice that we have a graphical interface. Most Unix and Linux administrators very rarely use the graphical interface outside of maybe web browsers, things like that. Most of the things that you do in the Unix and Linux world are going to be command line, and especially on the server. And actually, Microsoft is kind of slowly but surely moving in that direction with their slimmed down Windows Server installs where you use PowerShell. So I think they're eventually going in that direction too. So let's go through a few more commands just to make sure we've got a few. So if I wanted to remove this file, I would do rm and then the file name. And if I wanted to remove this directory, it's probably not a good idea to remove it while I'm in there. So what do you think we should do? Yeah, maybe go up a level, cd ... Now, removing directories is, okay, so the official way to remove a directory is there is actually a separate command, rmdir. To be perfectly honest, I almost never use this command. The reason being is, so let's go through a quick experiment here, okay? So what I'm going to do is I'm going to make the dir again. So we called it Testdir. And then let's touch that hello file. So just a quick note, we don't have to actually change into the directory. What we can do is we can say within Testdir, go ahead and touch hello. Remember the slashes, how they work? Now if we list the contents of the test directory, we can see that we have hello in there. The reason I almost never use the rmdir command is because watch what happens if we try to remove that directory and there's a file in it. Now it's very, very, very rare that you actually remove a directory and it doesn't have files in it. You know what I mean? It's like you just have to be lucky. Almost everything's going to have files in it or other directories, or, you know, because we can put directories within directories. So we actually have instead is recursive remove. And what that does is the recursive option that goes into every single directory and subdirectory and recursively keeps on going all the way down until all the files, all the directories and files are all cleared out. Does that make sense? So the way we do that is we do rm minus r. Minus r standing for recursive, testdir, And that recursively does it. So it went in there and it cleared out all the files before it tried to remove it. Okay, everyone good so far? I'm not trying to cover too much in one day. A couple more things. This is just, again, this is just to move you through, and then we'll start using other things. Okay. So we covered touch. Let's do this. So back in the old days of computing, before networking was common, we wanted some sort of built-in documentation system. And the built-in documentation in Linux and Unix is man, short for manual. So if we don't remember everything about a command, we type in man, let's say the command ls, and that'll give us everything we want to know about ls. There was an effort, so a lot of these man pages can be gigantic. There was an effort to create kind of the next generation of man called info. And just for whatever reason, I've noticed it just hasn't caught on nearly as much. Like, people still use man for the most part. So I'm not going to really talk about info. But you can see here, this gives us a complete description of everything. So remember we talked about -L before? It says use a long listing format. Okay. Unix people are known for being very cranky, and so for many years, if you asked a question, oftentimes they would just tell you to read the man page, and that'd be very helpful. In 2020, the landscape's changed a little bit, because now what do we have? We have the web, we have internet access, and so if you're trying to do something that's a little bit out of the ordinary, then oftentimes you'll find yourself just Googling it or checking Stack Overflow or something like that. Now, I still use man pages all the time, but it's the landscape's changed a little bit. If you know it's just an option within, let's say, ls, there's no point in Googling it. That's a little bit, you're going to get all kinds of crazy answers. A lot of times it's just easier just to go to the man page. Okay. And then to get out of this, we hit Q for quit. A couple other things. So if we want to view all the processes on our system, that command is ps. Now you notice it's not really, there's not a lot there. What this is giving us is just the user that we're currently running on as in this current sudo terminal, basically this terminal right here. We're running the bash shell, and because we were running the ps command, it also caught that. That's usually not super useful, so there's a bunch of different ways to display it. A lot of people like to use AUX. That's one. I actually like to use -EF, so you'll see me use that a lot in this class. The format is just a little bit more friendly for what we need to do. Yes?
Sorry, what does PS say?
Oh, it's for processes, and it'll show us all the processes. And every process gets a numeric process ID. The reason we might want to do that is because we may need to kill that process if it's like gone out of control. If we had it running in the background, we might want to reattach to it. So there's reasons for needing to know this process ID. But
And what's EF?
I've been using it for so many years, I don't remember. But we can go to the man page. I think E stands for extended. So we can do. Oh, sorry. So all processes, and then F. Oh, full format listing. So it gives us everything. So if we had just done PSE, it would have shown us the short version, but I typically like to have more information. So this tells us, you can see here, this gives us a lot more information. What else? Oh, and then so there's a command called top that basically tells us what our system is doing, gives us a pretty decent idea how much memory is being used, the top processes, and so forth. Now there's a slightly more modern version of this that I noticed people tend to use. I kind of like it too. It's called htop. Now by default, we don't have that installed. What's nice within Bash, it has this like integration that if you try to type a command that's not installed, it tells you how to install it. Now remember what I told you is normally in the Windows world, if there's a program that I want and it's not installed, what do I have to do? I have to go out on the internet and find it. Within the Linux world, this idea of the central repository is very common. And so there's Ubuntu servers out there and Debian servers that they have all these programs and binary files and so forth. And what app does is it actually goes to those servers and it lets us download that. So what you can do is, let's go ahead and type that in. I'll explain sudo at some point. Basically, sudo temporarily lets us run the command as root. And so let's get this htop program. And then now if we type htop, it's a little bit more user-friendly. Gives us a nicer display of really what's going on. Okay, so I think that's pretty much all I want to cover this week. Mainly I just wanted to get you used to being able to move through the directory structure, being able to create files, delete files. Oh, let's cover one more thing. Did we talk about copy? Let's talk about copy and move. I think I skipped over those, right? I didn't talk about those? Okay. I guess I should have kept a little something going on. Okay. So let's touch hello. That creates an empty file. Now, even though we don't have to use file extensions, sometimes it's just a nice thing to have. So there's no rename command. We use move, MV. And that actually means that we're moving the file. So moving and renaming are essentially the same thing. Okay. So if I wanted to move it, I would do MV, the original file, and then what I want to move it to. Let's say hello.txt. And if we wanted, so if we do an ls, we can see that in here now, hello.txt. If I wanted to copy it, I would do cp hello.txt. Let's just say hello2. Now we can see here we have a couple of copies.
So CP is copy prop.
It's just short for the full word copy, so just CP. Now, one quick note. Let's say, for example, I've got this pictures, okay? CP pictures. By the way, I guess I should have noted this earlier. In the Unix, Linux world, files and directories are case sensitive. So notice how they use capital P here. I'd have to type it in with a capital P. And let's say I wanted to call it pictures.back, which is very common to make a backup. We just do .back. Now notice that it's complaining. So when you copy a directory, you can't just do the copy command. There's -R for recursive, but there's actually one I like using a little bit better. called -A, and this is called archive mode. This actually is a bunch of different options in one. It keeps all the permission. It basically keeps all the permissions and everything, and it keeps a lot of things intact. That's why they call it archive. So you can do CP -A. Okay. I think that's pretty much it. I know we have to get going here. So any questions? What I'll probably do is provide some sort of cheat sheet. If there's got to be one online, I'm pretty sure there is. Some sort of summary sheet, because I know it's going to be difficult to keep all these in your head. So some sort of cheat sheet, maybe you can print it off, and I'll post that online just so you can kind of maybe have that handy. But I think that's pretty much it for this week. So any questions? That just kind of gets you moving through the system. Yes?
How much overlap do we see between things like Ubuntu and Red Hat and like Debian?
A huge amount on the core stuff. So all these commands are going to be the exact same. The places where they slightly differ, one of the big things is that /etc directory. They're going to be a little bit different. They all use the same shell. They all tend to use bash pretty much across the board.
I use like sudo apt get.
And that's the other big thing is their package managers are different. So in the very quickly, in the Ubuntu Debian world, they use it's called apt, and in the Red Hat Fedora that world they use a package manager. So they use a package format called RPM, and their package manager is called yum. So
for instance, if you wanted to install like screen fetch on like Red Hat versus Ubuntu would be like sudo apt install
package name. It'd be typically the commands are somewhat similar. So you do yum install and then
yum.
Yes, yeah.
Okay.
It stands for Yellow Hat or Yellow Dog package manager, something like that. There used to be a Linux distribution for PowerPC called Yellow Dog Linux, and that's where they still
Seems
have.
like with Linux, just don't think about it too much. Just learn the commands and just.
Yeah, if you try to, it's not like there was some.
Not all of them are sensical.
Yeah, there wasn't some master engineer sitting, making all these commands. It was usually some guy who took about 3 seconds to make a decision.
He didn't have to go up to a manager and be like, yellow dog.
Yeah, exactly. So, okay. All right. I know we have to go. So any last minute questions? Okay, cool. So next week what we'll do is we'll do an in-class lab. And if just you have any questions between now and next week, let me know. And I'll have this posted soon. Okay. Yes.
I have one question.
So if you need to go, you can head out, but I'll answer your question.
Since we're not using Skillport,
Yes.
would you suggest us get a book for the core?
You can still use the Skillport book.
Okay.
Because that'll still be useful. But I think what I'm going to do is just post links that I find useful and a lot of cheat sheets and summary sheets and that sort of thing. So I'll make sure to post stuff. I'm not going to leave you all by yourself. Okay. All right. Good job, everybody, and I'll see everybody next week. And just email me if you have any questions.